Wes.
Welcome and thanks for joining us. Today we're talking about your recent project, LLM performance evaluation,
Sports statistics analysis. Can you start with thing? Can you tell us what this project was about?
We compared ChatGPT, Claude, and Google AI search to see how well they could analyze songs.
Which model performed best?
Google AI search consistently outperformed the others, especially on basic lookups and handling missing data.
Enemies. What's the big takeaway from your research?
Data quality matters as much as the model. Structured inputs like CSV or JSON. Structured inputs like CSV or JSON are essential for reliable analytics.
Imagine for a moment you're staring down just a mountain of sports statistics. You know, team performance, individual player records, trends stretching across multiple seasons.
Yeah, a lot to sift through.
Exactly. Now, picture an advanced AI trying to make sense of all that, but here's the catch, D. The data isn't neatly organized. It's buried in these messy, sometimes incomplete PDF files.
Right. So what kind of insights could it possibly unearth? And maybe more importantly, what challenges would it face doing that?
Well, it's a scenario that probably hits close to home for anyone working with data, I imagine.
Absolutely.
Yeah.
Real-world information, it rarely comes in those clean, structured packages we all, hope for.
That's precisely why this deep dive is so compelling. We're unpacking a fascinating study that really put leading large language models, players like ChatGPT, Claude, and Google AI search to the test.
Okay.
Their mission, analyze genuine, unstructured sports data. So our goal today is to give you a shortcut, basically, to understanding their strengths, their surprising weaknesses, and what these findings mean for, well, anyone who works with data.
Whether you're in analytics, coaching, or just curious.
Exactly.
And the source material here is incredibly relevant because it reflects that real-world messiness you mentioned. The study focused on Syracuse women's lacrosse data, specifically from the 2023 to 2025 seasons.
Okay.
And this wasn't some pristine, pre-processed database. All the information was locked away inside PDF documents.
Which, as you said, were often incomplete and pretty messy.
That's right, a real challenge.
So let's set the stage a bit more. What was the core objective here? What were the researchers truly hoping to find out by feeding these, let's say, less than perfect PDFs to these very advanced AIs?
Well, the primary goal was pretty clear. Evaluate how these three major LLMs handled authentic sports statistics. They wanted to see if these, general-purpose AIs could actually pull out meaningful insights.
From data that usually needs a human, or maybe specialized software.
Exactly. Data that usually requires human interpretation or custom-built tools. It was fundamentally a test of their adaptability and, I guess, their robustness.
Okay. And beyond just the raw data itself, what kinds of questions were they asking these models? Was it just simple fact-checking, or were they pushing them harder?
Oh, it was definitely a mix.
Yeah.
A pretty comprehensive approach, actually. The questions ranged from basic factual recall, things like specific win-loss records or games played.
Simple stuff.
Right. But it went up to questions requiring more complex reasoning, even deeper analytical insights like spotting trends over time. The idea was to gauge a whole spectrum of understanding.
That data format, the PDFs, that really stands out as the critical hurdle, doesn't it? For anyone maybe less familiar, what makes a PDF so tough for an AI to parse accurately compared to, say, a nice, clean spreadsheet?
Yeah, that's a good question. So PDFs, they're designed primarily for humans to read, right? Consistent look and feel across devices. But they don't inherently store data in a way that's machine-friendly or structured. Text and numbers might look perfectly lined up to our eyes, but to an AI, they can just appear as, like, images or strangely positioned characters, maybe text boxes that aren't logically connected.
So it's not like reading a digital text file.
Not at all. It's more like trying to understand a book by only looking at slightly blurry photos of its pages. This forces the AI to lean heavily on something called optical character recognition, OCR, just to even begin extracting the text.
That's a great analogy. Sounds like a major barrier before any real analysis can even kick off. So, all right, they put these digital contenders through their paces. Who came out on top? Who was the MVP of this data analysis challenge?
Well, in this specific setup, Google AI search was the standout performer. It consistently delivered the most accurate results, especially with those basic facts, games played, win-loss records, that kind of thing.
Okay, so Google took the lead. Delving into the specifics a bit, what did Google AI search manage to do that really highlighted its precision, particularly where the others seemed to stumble?
Yeah, the really telling detail was its ability to correctly identify the top scorers for each individual season. It accurately named Megan Terrell for 2023, Emma Terrell for 2024, and Emma Ward for 2025. This wasn't just, hitting one data point correctly. It showed this remarkable consistency and precision across multiple seasons, multiple specific stats.
Which the others just couldn't match.
Couldn't replicate, no.
Yeah.
Not with that level of accuracy.
That is impressive, especially given the messy input. So if Google AI search was the clear winner, where did ChatGPT and Claude fall short? What kinds of errors were tripping them up?
Their main struggle, it really stemmed from significant OCR parsing errors.
Yeah.
You have to picture the AI misreading, say, a f as an S because of a slight blur or smudge in the PDF,
Right.
or maybe an entire table appearing misaligned, just slightly off, causing the model to completely garble the numbers associated with it. These weren't just minor glitches. They were pretty fundamental misinterpretations of the raw data.
So errors right at the starting gate, basically, at the data ingestion stage, before they even got to the complex analysis.
Precisely.
Can you give an example of how that actually showed up in their answers?
Sure. So when asked about those top scorers we just mentioned, ChatGPT and Claude either misread the stats completely, often attributing the wrong numbers to players, or they just skipped entire seasons.
Suggesting they just couldn't pull the info reliably.
Exactly. And, maybe most surprisingly, they also made errors in what you'd think would be straightforward arithmetic. Things like calculating percentages or ratios.
Even when the numbers were sort of there.
Even when the underlying numbers seemed present in the text they extracted, they still sometimes got the math wrong.
Wow. That's quite striking. You have these incredibly advanced AIs, right? Capable of generating complex text, poetry, code.
Yeah.
And they're stumbling on basic math because the input data was messy. It really hammers home how much the quality of the raw material impacts everything, even fundamental operations.
It absolutely does. It highlights that these models are, at their core, powerful pattern matchers and language predictors, but their, let's say, computational accuracy can definitely be compromised when the source data is noisy or ambiguous.
Okay, so beyond just recalling facts and figures, did any of them manage the deeper analysis? Like spotting broader trends over time? Or was that just too much to ask, given the PDF problem?
This is where it gets really interesting, actually, because yes, all three models did manage to identify a key trend.
Oh, they did?
Yeah, they all noticed that Syracuse's performance against top 10 ranked teams seemed to decline over those specific seasons, so they could, in fact, perceive some macro-level patterns.
That's fascinating that they all picked up on the same trend, but I'm guessing there was maybe a difference in the quality of that observation. Did they all offer the same level of detail or accuracy?
Not at all. You guessed right. Google AI search, sticking to the pattern, provided the most accurate and detailed breakdown of this decline. It offered a clearer, more nuanced picture.
And the others?
ChatGPT and Claude, while they did note the trend, tended to offer only partial or sometimes inconsistent answers. It made their insights less reliable if you wanted a full understanding. So, yeah, they saw a pattern, but the depth and precision of that insight varied significantly.
Right. Okay, so given these different performances, and especially where ChatGPT and Claude struggled, what would you really pinpoint as the biggest roadblocks for these LLMs when they're dealing with this kind of real-world, messy data?
Number one limitation. Without a doubt, it was those OCR parsing errors we talked about. Misaligned tables, misread numbers in the PDFs. It meant the models were often working with incorrect or corrupted data right from the start.
It wasn't an AI logic problem then?
No, fundamentally an input problem.
Oh.
Which it immediately brings to mind a crucial takeaway for you, our listener. The quality of the raw material directly dictates the quality of the output. Doesn't matter how sophisticated the tool is.
Garbage in, garbage out, basically, even for AI.
Pretty much. If the foundation is shaky, the analysis built on top is inevitably going to be flawed. The second major limitation was simply missing statistics.
Data just wasn't there.
Exactly. For
Yeah.
example, player-level data for the 2024 season was often completely absent in the source PDFs. So if you're a coach trying to plan for next season, the AI can't just invent a star player's 2024 stats out of thin air.
No matter how smart it seems.
It can only work with what it's actually given.
Makes sense. And then there was that surprising third limitation we touched on earlier, the arithmetic.
Right, the math. Even when the data was present and seemed legible, the models occasionally miscalculated. For all their incredible advancements, it's just a stark reminder that these LLMs aren't, infallible calculators.
Yeah, that's a key distinction.
It is. They're prediction engines, primarily optimized for language generation and finding patterns, but they aren't always precise computational machines, especially when pulling numbers from noisy text. Something to keep in mind if you're relying on their numerical output.
So, faced with these pretty significant roadblocks, how did the researchers try to improve things? They couldn't just magically clean up the original PDFs, right? So this is where that skill of prompt engineering becomes really crucial.
It is absolutely crucial. They experimented quite a bit with prompt engineering. For instance, instead of just throwing one big request at the model like extract numbers, analyze, calculate all at once,
Yep.
they broke the task down. They first prompted the models to just extract the raw numbers they could find. Then, in a separate step, they asked them to perform the calculations based on those extracted numbers.
Ah, that's smart. Like
Yeah.
telling someone, okay, first gather the ingredients, then follow the recipe, guiding the AI through a more structured process.
Exactly like that. Another really effective strategy was requiring the outputs in a structured format, specifically JSON.
Okay, what's JSON?
It's essentially a highly organized, machine-readable way to present data.
Mm-hmm.
Key value pairs, very structured. It makes the responses much clearer and more consistent than just free-form text.
Easier for analysis later, I bet.
Definitely. And crucially, they also instructed the models to explicitly state insufficient data when the information simply wasn't there in the PDF,
Rather than guessing.
rather than guessing or, even worse, hallucinating an answer, which LLMs can sometimes do.
Okay, so they tried breaking down the task, structuring the output, telling it to admit when it didn't know. Did these prompt engineering strategies actually work? Did they see a significant drop in errors?
They did, yeah. These strategies significantly reduced errors across the board for all the models. It was a powerful demonstration that how you ask the AI, how you structure that interaction, it matters immensely, especially when you're dealing with inherently messy input.
So the human guiding the AI can compensate for some of its limitations.
That's a great way to put it. It allows humans to compensate and get better results.
It really is a powerful lesson in how crafting the right prompt can unlock much greater potential from these tools. So looking ahead then, what's next for this line of research? Where do they go from here, having seen these initial results?
Well, the immediate next step is pretty logical, is to pre-process those difficult PDFs into structured formats like CSV files or JSON files before feeding them to the models.
Ah, clean the data first.
Exactly.
Mm.
That effectively removes the whole OCR noise problem and will allow for a much fairer test of the LLM's true analytical capabilities without that confounding factor of poor data extraction messing things up.
Leveling the playing field, essentially, makes perfect sense. And beyond just cleaning the input, what about future explorations? Are they thinking about, say, predictive analytics? Or maybe comparing these general LLMs against more specialized sports models?
Both, actually. They definitely plan to expand into predictive analytics, things like forecasting win-loss records, which obviously has very practical applications in sports.
Huge interest there.
For sure. And yes, a critical next step is also to compare how specialized domain-specific sports models perform against these big general-purpose LLMs like ChatGPT or Google AI.
That'll be fascinating to see if a generalist can really compete with a purpose-built tool in a niche area.
Exactly. That comparison will be crucial for understanding the trade-offs and where each type of model really shines.
This whole process really highlights the ongoing evolution, doesn't it? How we develop and apply AI for practical problems. It's not static. It's constantly adapting, learning from its limitations, being refined for real-world use.
It's a continuous cycle, absolutely.
Yeah.
Testing, learning, improving, testing again.
So let's bring it back. What does all this mean for you, our listener, maybe in your own work or interests?
I think the big overarching lesson from this deep dive into LLM performance with messy sports data is incredibly powerful and practical.
Yeah.
It's that data quality matters just as much as the model itself, maybe even more sometimes.
That really is the crux of it, isn't it? Even the most advanced, sophisticated large language models are going to struggle. They'll misinterpret or just plain fail if the input data they're given is noisy, unstructured, or incomplete.
Whereas clean, structured data,
Clean, structured data, think those perfect CSVs or well-maintained databases, that makes all the difference if you want reliable analytics and insights you can actually trust. The AI, ultimately, can only be as good as the information it consumes.
and this really raises an important question, maybe a final provocative thought for you to consider. What kind of data are you working with? In your job, your hobbies, whatever it is.
How might its inherent messiness, its imperfections, be silently impacting the insights you're getting, even if you're using the smartest, most cutting-edge tools available?
It's a really crucial point.
It is. It's a profound reminder, I think, that even in this incredible age of AI, that human element, the careful data preparation, understanding the source, knowing its limitations, that remains absolutely essential.
You know, we hear it all the time, right? That AI is changing the world. But what happens when you take it out of the nice, clean lab and throw it at something, well, something really messy, like real-world sports data? We're about to put today's biggest AI models through the ultimate stress test to see if they can actually hang.
And that gets us to a pretty huge question. Could an AI really replace a human sports analyst? Well, to figure that out, some researchers set up this fascinating challenge to see if today's top models would sink or swim.
So, here's the setup. It was a face-off to see which AI could make sense of 3 whole seasons of stats from the Syracuse women's lacrosse team. And listen, this was not just a simple data lookup. This was a high-stakes test of their actual analytical brain power.
And our contenders? They're the 3 heavyweights in the game right now: ChatGPT, Claude, and Google's AI search. All 3 were fed the exact same messy data to see who would come out on top. Let the games begin, right?
But here's the crucial twist. The AIs were not handed nice, neat spreadsheets. Oh no. They had to dig through messy, sometimes incomplete PDF files from 3 different seasons. This wasn't about finding data, it was about excavating it. So, after putting these powerful AIs up against all this messy data, who actually won? The models were grilled with all sorts of questions, facts, reasoning, analysis, and the results? They were pretty surprising. Okay, so when it came down to just getting the basic facts right, simple stuff like games played or win-loss records, there was a clear runaway winner. Google AI search consistently pulled the correct information, while both ChatGPT and Claude, well, they struggled a lot. But this raises a huge question, doesn't it? I mean, these are some of the most sophisticated AIs on the planet. Why in the world did they stumble on something as basic as reading facts from a document? What exactly went wrong here? So to figure it out, the researchers really dug into the errors. And what they found, it actually reveals some pretty fundamental limitations of AI as we know it today. Take this, for example. They asked a simple question: who was the top scorer each season? Only Google AI search got it right, correctly identifying Megan Terrell, Emma Terrell, and Emma Ward. The other models, they gave back wrong names, incomplete data, or sometimes just flat out gave up. This one question really shows you the performance gap. The investigation boiled it down to 3 main culprits. First, these technical glitches called OCR parsing errors, and we'll get to what that means in a second. Second, some stats were just plain missing from the files. And third, and this one is kind of shocking, the AIs made simple math mistakes. Even when they had the right numbers, they'd get the final calculations wrong. So what is this OCR parsing thing? Well, think of it as the AI's eyes. It's the process of scanning a PDF and turning the picture of the text into actual data the computer can understand. But just like our eyes can get tricked, if a table in the PDF is just a little bit crooked, the AI gets confused and starts misreading things.
And this is a huge deal. A tiny little OCR glitch could misread a player's name, or it might mistake a 6 for an 8. To the AI, that small error completely changes the facts, and then boom, the entire analysis is flawed right from the very beginning.
So does this all mean these AIs are useless for looking at data? Not at all. Actually, the researchers discovered something pretty remarkable. You can dramatically improve the results, not by changing the AI itself, but by changing how you ask the question. They developed this really clever 3-step method. First, extract first. They told the AI, hey, just pull the raw numbers for me, no math yet. Second, force structure. They made the AI give them the output in a format called JSON, which is basically just a super organized list that computers love to read. And third, and this is a big one, forbid guessing. If the data wasn't there, the AI had to admit it. And just those 3 rules slash the number of errors. All of this, it leads to the single most important lesson from this entire experiment. And it's not about which AI is smarter. Nope, it's about something way more fundamental. The biggest, most crucial takeaway from this whole study is this: the quality of the data you feed an AI matters just as much, if not more, than the AI model itself. So you see, the real competition here wasn't ChatGPT versus Google at all. It was messy, unstructured PDF data versus clean, organized data. And when it comes to how well an AI performs, the difference between those two is night and day. It just proves that even the most advanced, most powerful large language models can't work miracles if you give them bad stuff to work with. It all comes down to the oldest rule in computing, right? Garbage in, garbage out.
Which leaves us with a final and I think really critical question. We're all racing to ask what AI can do for us, but maybe, just maybe, the first question we should be asking is much simpler. Is our data even ready for AI?